Dear students, in the previous two videos I have explained about complex number definition and algebra of complex numbers. Also we have solved exercise 1A problems. Okay, now in this video I am going to explain the clear idea about the conjugate of a complex number and some of its properties, and next how to find square root of a given complex number. Okay, so these are the two concepts which we are going to learn in this video. Okay, so first one, what do you mean by conjugate of a complex number? Now the definition of conjugate of a complex number, simple definition: the complex conjugate, this is also pronounced as complex conjugate or conjugate of a complex number z is equal to x plus iy, is denoted by z bar. Okay, so z is equal to x plus iy is a complex number, so the conjugate is denoted with z bar. Okay, so put a line on z, that is called as z bar, read as z bar, which is equal to x minus iy. Simple, the conjugate of a complex number is the complex number, it is also a complex number, it is obtained by just replacing I by minus I. Okay, just replace I with minus I. Okay, if it is I with minus I, then we will get a conjugate of a complex number. Okay, so for example, if z is equal to 5 plus 6i, then its conjugate z bar is equal to what? 5 minus 6i, just I with minus I. Okay, so if we apply again conjugate, so z bar whole bar, conjugate of a complex number, then again replace I with minus I, minus into minus plus I, 5 plus 6i. So again we will get the same conjugate number, same complex number. So from this we can write it as z bar whole bar is equal to what? Z. Okay, next one more observation. So if we add these two, z plus z bar is equal to iy gets cancelled, x plus x what? 2x. From this x is equal to z plus z bar by 2. Okay, that means real part of z, x is nothing but real part of z, is equal to z plus z bar by 2. Okay, and similarly if we subtract z minus z bar, then it become minus x, this is become plus iy. Okay, minus x plus x will get cancelled, we will get 2iy. Z minus z bar is equal to what? 2iy, and y is equal to what? Z minus z bar by 2i. Okay, so y is called as imaginary part of z. Imaginary part of z is equal to z minus z bar by 2i, and the real part of z is equal to z plus z bar by 2. Z plus z bar by 2. So remember these 3 points, and some more properties we are going to observe. Now some of its properties. First one, z is equal to x plus iy, then z into z bar is equal to x square plus y square. Simple, if z is equal to x plus iy is a complex number, then z bar is equal to what? X minus iy, just replace I with minus I. Now multiply these two, so x plus iy into x minus iy. Now x, these are in the form of a plus b into a minus b, that means a square minus b square. So x square minus I square value is minus 1, right? I square, already we have learned that I square is equal to minus 1. So z into z bar is equal to x square minus into minus plus y square. So if z is equal to x plus iy, then z into z bar is equal to what? X square plus y square. Now second property, conjugate of sum of the two complex numbers is equal to sum of their conjugates. So z1 plus z2 bar is equal to z1 bar plus z2 bar. Proof. Let us take z1 is equal to x1 plus iy1 is a complex number. z2 is equal to x2 plus iy2. From this, conjugate of z1 is x1 minus iy1 and conjugate of z2 is x2. Just replace with I with minus I. Now z1 plus z2 is equal to what? Just sum of these two complex numbers, that is x1 plus x2 plus I into y1 plus y2, right? Sum of real parts and sum of imaginary parts. Now take left hand side part, that is z1 plus z2 conjugate. So this is z1 plus z2, then apply conjugate to this one, replace I with minus I, we will get x1 plus x2 minus I into y1 plus y2, right? Now x1 plus x2 minus I into y1 minus I1 minus I y2. Write x1 minus I y1 in one bracket and x2 minus I y2 in another bracket. What is x1 minus I y1? z1 conjugate of z1, x2 minus I y2 conjugate of z2, which is equal to RHS. So conjugate of sum of two complex numbers is equal to sum of their conjugates. Okay, so therefore z1 plus z2 bar is equal to z1 bar plus z2 bar. Next, third one, z1 minus z2 bar is equal to z1 bar minus z2 bar. Simple. Z1 minus z2 bar can be written as z1 plus minus z2 bar. So by applying previous rule, that is z1 plus z2 bar is equal to z1 bar plus z2 bar, right? So here z1 bar plus minus z2 bar, we can apply like this, minus 1 bar into z2 bar. Okay, now conjugate of any real number is itself real number only, minus 1 conjugate minus 1 only. So z1 bar plus minus z2 bar, so which is equal to z1 bar minus z2 bar. Okay, simple. Here I have used that property, that is z1 into z2 bar is equal to z1 bar into z2 bar. So which I will prove in fourth one. Okay, otherwise you can solve this problem like a previous method. Take two complex numbers and do subtract it and apply that one, you will get. Okay, so similarly we can prove in second proof manner. Otherwise we can use we can prove by using z1 plus z2 bar is equal to z1 bar into z2 bar. Now next fourth one, z1 z2 bar is equal to z1 bar into z2 bar. Conjugate of product of two complex numbers is equal to product of their conjugates. Okay, so let z1 is equal to x1 plus iy1. Next z1 bar is equal to conjugate of z1 is equal to x1 minus iy1. Next z2 is equal to x2 plus iy2. Then z2 bar is equal to x2 minus iy2. z1 into z2 is equal to, already we have solved this one in previous videos, product of two complex numbers. Now z1 z2 bar is equal to, just replace I with minus I, we will get x1 x2 minus y1 y2 minus I into x1 y2 plus x2 y1. So this is left hand side. Now what is right hand side? Simplify z1 bar into z2 bar. What is z1 bar? x1 minus iy1 into x2 minus iy2. Now x1 into x2, x1 into minus I x1 y2 minus I x2 y1 minus into minus plus I square y1 y2. Okay, now x1 x2 I square is minus 1 into y1 y2 minus y1 y2. From these two minus I is common, x1 y2 plus x2 y1 is remaining. So from 1 and 2, from 1 and 2 we can write, z1 plus z1 z2 bar is equal to z1 bar into z2 bar. So these two are equal, right? Therefore left hand sides are also equal. z1 into z2 bar is equal to z1 bar into z2 bar. Next, fifth property, conjugate of 1 by z2 is equal 1 by conjugate of z2. So first take left hand side part, that is 1 by z2. Let us take z2 as x2 plus iy2 whole conjugate. This can be written as first of all, okay, multiply numerator and denominator with x2 minus iy2 its conjugate and bar, apply bar, x2 minus iy2 by, this is a plus b into a minus b, right? x2 square plus y2 square minus I square y2 square. I square value is minus 1, minus into minus plus. Now apply conjugate, we will get x2 plus iy2, replace I with minus I, we will get this one. So this is left hand side part. Now take right hand side part, that is 1 by z2 bar. z2 is x2 plus iy2, z2 bar means x2 minus iy2. So multiply numerator and denominator with its conjugate. So you will get x2 plus iy2 by, this is x2 square plus y2 square. I square is minus 1, minus into minus become plus. So we got same answers. Therefore from both we can write it as 1 by z2 bar is equal to 1 by z2 bar. Next, sixth property, conjugate of z1 by z2 is equal to conjugate of z1 by conjugate of z2. So take left hand side part, z1 by z2 conjugate can be written as z1 into 1 by z2 whole conjugate. So this is of the form z1 into z2. So we can apply conjugate to both individually. Okay, so here I applied z1 z2 bar is equal to z1 bar into z2 bar. Okay, now z1 bar into, just now we have discussed 1 by z2 bar. 1 by z2 whole bar is equal 1 by z2 bar. So now multiply, you will get z1 bar into 1 z1 bar by z2 bar, which is equal to RHS. So z1 by z2 whole bar is equal to z1 bar by z2 bar. Conjugate of quotients is equal to quotient of their conjugates. Now next important topic is square root of a complex number z is equal to a plus ib. So how can we find a square root of a given complex number? Okay, let z is a complex number a plus ib. It is denoted with z, which belongs to complex number set. If w is another complex number is such that w square is equals to z. Okay, so let w is equal to root square root of z, then after squaring on both sides we will get w square is equal to z. So then w is called a square root of a complex number z. Okay, now how can we find a square root of given complex number? Z is equal to a plus ib. Okay, here we have two cases. In first case, if b is equal to 0. If b is equal to 0, in case 1 I am taking b is equal to 0. If b is equal to 0, then what happens? Okay, so this imaginary part becomes 0, it will vanish. Then w square is equal to z, right? Then w square is equal to z is equal to a. That means w square is equal to a. Okay, now here we have two cases. One is a may be positive, a may be negative, a greater than or equal to 0, a less than 0. So if a is positive, in this case w is equal plus or minus root a. Here a is positive real number, right? Okay, so in this one a is real number, b is real number. If a is positive real number, then w is equal plus or minus square root of a. If a is negative real number, okay, then we will get root a only. Here it is here minus 1 is not there. Here a is negative, a is negative. So negative means minus 1 into positive. Minus 1 root is plus I, and that positive, this minus a become positive. A is negative, right? Minus a become positive. So then w is equal plus or minus I into root minus a. That is the value. Okay, so in this case, if b is equal to 0, we will get two cases again. One is a is greater than or equal to 0, and another one is a less than 0. Like if the, for example, z is equal to 3, okay, 3, or z is equal to minus 3. If 3 is positive, then w is equal to what? W square is equal to 3, w is equal plus or minus root 3. Here we have negative, right? So w is equal plus or minus root minus 3. So in this case, plus or minus minus 1, square root of minus 1 is I. Then we will get root 3 into I. Root 3 into I. Square root of minus 1 is I, right? So like that we will get. These are the two examples for this case. Next, second case, suppose b is not equal to 0. That means imaginary part is not equal to 0. Then what happens? So here, as per our condition, w square is equal to z, right? So let w is x plus iy whole square is equal to z is a plus ib. Okay, I am taking w as another complex number, that is x plus iy, z is a plus ib. Now squaring, after squaring we will get x square plus iy whole square plus 2 into x into iy is equal to a plus ib. Then x square I square is minus 1, that is minus y square plus I into 2xy is equal to a plus ib. Now comparing on both sides, we will get a is equal to what? X square minus y square, and b is equal to 2xy. Okay, now I am going to find, it is equation number 1. I am going to find x square plus y square, x square plus y square whole square. So what is the formula for x square plus y square whole square? X square minus y square plus whole square plus 4x square y square. So a plus b whole square is equal to a minus b whole square plus 4ab. This is the formula. Okay, now x square minus y square whole square is nothing but a square plus 4x square y square is nothing but 2xy whole square. That means b square. B square means 4 square, 2 square means 4x square y square. So from 1 we have written x square minus y square whole square as a square, and 4x square y square b square. So this is x square plus y square whole square. Now from this, what is x square plus y square? X square plus y square is equal to what? Under root of a square plus b square, right? Under root of a square plus b square. Now if we add these two, we will get what we have to add. So by adding these two, this is equation number 2. Now add 1 and 2, we will get 1 and 2, we will get x square plus y square is equal to root a square plus b square, and x square minus y square is equal to a. These two gets cancelled. 2x square is equal to root a square plus b square plus a, and x square is equal to root a square plus b square plus a by 2. So square remove square, we will get plus or minus root a square plus b square plus a by 2. So similarly, this is equation number 3. Similarly, subtract these two, you will get y is equal to plus or minus root a square plus b square minus a by 2. Okay, right. So x is equal plus or minus root a square plus b square plus a by 2, and y is equal to plus or minus root. Okay, so square, we will get root. If removes, similarly, if we subtract 1 and 2, we will get y is equal plus or minus under root of a square plus b square minus a by 2. Now here we have some two observations. Here b is equal to 2xy, right? Now z is equal to w square is equal to z, then w is equal plus or minus root z. That means x plus iy is equal to plus or minus root a plus ib. Okay, right. Here in reverse way we can write a plus ib is equal to plus or minus x plus iy. Okay, that means plus or minus x plus iy. X is what? Okay, so if we take x, in this case b is equal to xy, right? So if x is positive, y is positive, then b become positive. If x is negative, y is negative, again b become positive. Observe here, if x, y both are having same sign, means both positive or both negative, then b become positive. If they are in opposite sign, one is positive and one is negative, x negative, y positive, then b become negative. So if b is negative, then what happens? If b is positive, what happens? Okay, so root a plus ib is equal to plus or minus, what is the value of x? Root a square plus b square plus a by 2 plus root a square plus b square minus a by 2. So this happens if b is positive. If b is positive, when b is positive, whenever x and y both are having same sign, means both are having plus or both are having minus. If both are having minus, we take minus as common, become plus or minus only. And they are having opposite sign, plus a by 2 minus under root of a square plus b square minus a by 2 if b is negative. If b is negative, means if b, whenever b become negative, one is positive, one is negative. If we take one is positive and one is negative, here one positive, one negative into plus. Okay, so in another way, x is negative, y is positive, means negative, positive. Take minus as common, again we will get same answer. Okay, so this is the formula for square root of a plus ib. To find the square root of a complex number, we have this formula. This is for b greater than 0. If b greater than 0, we should use this formula. If b negative, we should use this formula. In any case, we will get two roots. Okay, square root of a complex number, we will get two complex numbers. Okay, so geometry of geometry of these complex numbers and nth root of a given complex number. Okay, we will learn in next chapter. Okay, there I will give geometry of these two roots, and also I will explain about nth root of a complex number. Okay, so this, remember this formula. In next video we will solve the problems related to conjugate of a complex number and square root of a complex number. Sorry, here I should write I. Okay, y means x plus iy, right? So here this is the value of x and this is the value of y. In middle we should write I also. Okay, so this is the correction.